Let's solve this question using stalling and operand forwarding. I told you in the previous video, in the automatic operations, if solve R6, R4, R2 is given, it means what? Do R4 minus R2 and store in the R6. But in the load and store, it's exactly opposite. It means what? Load R6, 8 R5. It doesn't mean store the value of R5 into R6. It simply means store the value of R6 into R5. Okay. In the automatic operations, the value is stored in the left side, but in the load and the store, the value is stored in the right side. Okay. Simply like if there is load R1, R2, the value is stored, the value of R1 is stored in the R2. But if there is add R1, R2 and R3, then the value is R2 plus R3 is stored in the R1. It is only the difference you have to know in the load and store and the automatic operation. Let's solve this question using stalling and the operand forwarding. And this is also the important question in the exam point of view. There is no any. Let's solve with stalling first. Okay. Before doing the stalling, remember the 3 point. Okay. Before doing the stalling, remember 3 point. The updated value is always we get from the right back. Okay. No same stage is occurred in the same clock cycle. And third one is we cannot take the wrong value at the beginning. Remember this 3 point and solve the questions. First, there is no any instruction before the load, so the simply do if id ex me and write back. Load means what? Store load the value of R6 into the R5. Okay. Subtract R6, R4, R2. What is mean that? It means R4 minus R2 is stored in R6. Is there is any dependency? No, because here R5 is updated, but here is no any R5, so there is no any dependency. So we have to just simply do what we have done: if id ex me wb. Then what the question is? Load R4 to R6. It means what? Load the value of R4 in the R6. Is there a dependency of R4 before that? No. You tell here is a R4, but not, because R4 is changed when the value is stored in the R4, but value is stored in the R6 and the R5. So there is no end dependency. So we simply do if id ex me and the wb. Okay. Here R6 add with R4 and store in R1. Here maybe dependency or not. Check it. Yes, here dependency, because the value of R4 and R2 is subtracted and stored in the R6. It means in the second instruction, this R6 is dependent with the second instruction. It means we get a value of R2 here. Okay. And is R4 is dependent? No. It means if we get a value, if we get the updated value of R6, then we can perform this operation, add operation. Okay. This simply instruction phase. Can we take the value of id here? Sorry, can we take the value of R6 here? No, because I told in the previous video we cannot take the wrong value at the beginning in the stalling, and we know the value, the R6 value will get from the RB. Okay, then stall. Okay, stall. And WB, it means I can take the value of id ex me WB. And third point is, I told you not to start any instruction below the stalling. It means you cannot start from here. So you simply start from here. if. Okay. Multiply R1, R4 and store in R1. It means what? R1 into R4 and stored in where R1. Is R4 is dependent? No. Is R1 is dependent? Yes, because R6 and R4 is added and stored in the R1. It means this value is operated with this. And where I get this R1 value? 1, 2, 3, 4. Instruction 4 WB. So 1, 2, 3, 4. I get the value of R1 here. The IF. Can I take the value of R1? No, because we know that we cannot take the wrong value at the beginning in the stalling. So stall, then ID. Then here we get the value of ID. Then EX, ME, WB. Then total clock cycle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total clock cycle 12. Okay. Let's solve this question. Let's solve this question with the operand forwarding. Operand forwarding. For simple IF, ID, EX, ME, WB. Okay. Is there any dependency? R4, R2, R6. No, there is no any dependency. Okay. It means IF, ID, EX, ME, WB. R4 is stored in the R6. Is there any dependency? No dependency. Simply IF, ID, EX, ME, WB. Now this R6, R4, R1. Is there any dependency? Yes, this R6 is dependent with this. And I told you in the operand forwarding, we get all the automatic value after executions, and we get the value of load and store after memory. Okay, it means we get the value of this R6 after the execution of the subtraction. Okay, the last point is I told you, first of all we can take the wrong value of the registers, but before the execution we have to update it with the right value. It means instruction phase is this. Okay, R6 will get from here, because this is instruction second. It means after execution I will get my value R6 IF. I can take ID here, execution here. It means 1, 2, 3, 4, 5. 1, 2, 3, 4. It means after this I will get my R6 value, and here I am taking the wrong value. Okay, but before executions I want to update my value, so just update value from this EX, ME, WB. Okay, you can see that here while using the stalling, because we know that we only get the value of R6 in the right back. Okay, and we cannot take the wrong value at the beginning. So in the stalling we need one stalls, but in the operand forwarding I will tell first we can take the wrong value if it is necessary, then we can update it before it execution. Okay, then third one is, okay, multiply R1, R4 stored in R1. This R1 is dependent with this R1, and from where we can get this? After the execution of the instruction 4. It means 1, 2, 3, 4. It means I can get the value of R1 after the execution cycle. It means IF, ID. It means simply I get the operator value in the instruction decode stage. Then executions, memory, and WB. Just I get the operator value from there. Okay, the clock cycle 1, 2, 3, 4, 5, 6, 7, 8, 9. It means total clock cycle is equals to 9.